The X-ray universe at your fingertips. A million objects visible at high energies. You can now view the first data from the eROSITA X-ray Sky Survey. The catalogue, called ERASS-1, was made public on February 1 this year. This is the largest ever collection of information about the most powerful energy sources in the universe. The ERASS-1, eROSITA All-Sky Survey, catalogue includes, among others, exploding massive stars and active galactic nuclei powered by black holes that shine brightly in X-ray waves. In total, it presents an X-ray view inaccessible to our eyes of nearly half of the sky visible from Earth, including almost 1 million high-energy cosmic sources, including over 700,000 supermassive black holes. Data from the catalogue were published together with nearly 50 scientific articles on astronomy. In these publications, scientists also described the largest known structures in the universe, i.e., cosmic filaments of hot gas that connect galaxies into larger structures, galaxy clusters. The eROSITA X-ray Space Telescope is located about 1.5 million kilometers from Earth, near the L2 Lagrangian point. It is one of the main instruments on board the joint Russian-German SpecTR-RG mission. The latest results show that just 6 months after starting its scientific mission in July 2019, it has discovered more high-energy X-ray sources than had been recorded in 6 decades of previous sky research in this region of the electromagnetic spectrum. Now considered a breakthrough in the history of X-ray astronomy, the ERASS-1 catalogue can help us answer the most important questions in contemporary cosmology. How has the universe evolved so far, and why is it expanding at an increasingly faster pace? The main goal of the eROSITA program was to use galaxy clusters to study how dark energy accelerates this expansion of space. Project scientists point out, however, that the instrument and the data it has collected so far have already shown much more, going far beyond these initial assumptions. Publications based on the eROSITA database describe, among others, the discovery of over 1,000 so-called superclusters of galaxies and 2 quasi-periodically flared black holes. The ERASS-1 database also found 180,000 X-ray emitting stars in the Milky Way, 12,000 galaxy clusters, as well as more exotic high-energy sources, such as binary star systems, supernova remnants and pulsars. Interestingly, the collected data is also important for scientists studying extrasolar planets. Because among numerous works there is even an assessment of the impact of X-ray radiation emitted by stars on the ability to maintain water and atmosphere on the planets orbiting them. These are staggering numbers from an X-ray astronomy perspective, Andrea Merlini, eROSITA researcher and lead author of the catalogue, said in a press statement. We detected more objects in 6 months than the large flagship XMM Newton and Chandra X-ray missions did in almost 25 years of operation, he added. The ERASS-1 catalogue consists of the results of observations conducted by the eROSITA instrument from December 12, 2019 to June 11, 2020. During this period, It detected approximately 170 million individual photons of X-ray light. Data processing revealed 900,000 radiation sources, 700,000 of which were linked to supermassive black holes feeding quasars in the hearts of active galactic nuclei. The data now published are also remarkable because of the wide range of observations. The sky above Earth was imaged in many bands of X-ray energy. eROSITA is a highly precise instrument, and its observations include not only the sky coordinates from which individual photons are received, but also their arrival times and exact energies, along with the catalog and publications. The eROSITA consortium additionally provided software needed to analyze data from the mission. Iriam Ramos Seja, head of the eROSITA operations team, believes that making public high-quality data and codes for further scientific processing has the potential to increase the number of scientists working with X-ray data around the world, which could push the current limits of our knowledge in the field of high-energy astronomy even further. Source: Space.com, eROSITA, Photo, MPE, J. Sanders for the eROSITA Consortium. The photo shows images from the ERASS-1 survey processed using a special algorithm to separate X-ray extended objects, left, from point sources, right. The red, green and blue colors correspond to the X-ray energy bands in the range 0.3 to 0.6, 0.6 to 1.0 and 1.0 to 2.3 keV. Tests of mRNA therapy in cancer treatment have begun. UK cancer patients have been given the opportunity to take part in experimental mRNA therapy. The treatment is intended to help their bodies recognize and fight disease cells. In clinical trials, scientists will test the therapy for safety and its potential in cancer treatment. The first cancer patients in the UK have been given access to an experimental cancer treatment as part of a clinical trial. It's mRNA therapy, a type of immunotherapy called mRNA 4359. The aim of the study is to evaluate the drug's safety and its potential in the treatment of melanoma, lung cancer and other solid cancers. The therapy is designed to help the body recognize and eliminate cancer cells. It uses genetic material known as messenger RNA, or mRNA, and works by showing or presenting common tumor markers to the patient's immune system, which is expected to kill cells expressing those markers. The main goal of the new study, known as Mobilize, is to test whether this particular type of mRNA therapy is safe and tolerable in patients with lung or skin cancer, and whether it can shrink the tumor. Some patients will receive the drug on its own, but some will be given it in combination with the existing anti-cancer drug pembrolizumab. The therapy is in the early stages of testing, but scientists hope it could ultimately lead to a new treatment option for difficult-to-treat cancers, if the approach proves to be safe and effective. Preclinical studies in cellular and animal models have provided evidence that the new mRNA therapy has an effect on the immune system and may prove effective in the treatment of certain types of cancer. The authors of the therapy assumed that the immune system of a cancer patient should be trained to deal with the intruder. Showing the immune system what common tumor markers look like should help train it to recognize and fight cancer cells that have these markers, but also potentially remove cells that could stop the immune system from attacking cancer cells. In addition to understanding whether this new mRNA therapy is safe and tolerable to patients, researchers are also investigating whether combining this therapy with existing anti-cancer drugs can shrink tumors in patients with certain types of lung and skin cancer. New mRNA-based cancer immunotherapies such as mRNA 4359 offer a new opportunity to recruit a patient's own immune system to fight cancer. This research is still in its early stages and may take many years to be available to patients. But our work is laying important foundations that bring us closer to new therapies that are potentially less toxic and more precise. We desperately need them to turn the tide in the fight against cancer, said Dr. David Panato of Imperial College London. Patients taking the new therapy will be followed for up to 34 months.